Can you hear me? So yesterday we were discussing circles. Okay. Today we'll be discussing the same. Okay. Yesterday directly we have just discussed so many activities, and let me tell you what are the uses of that and what exactly is that. I'll be helping you. Okay, to remind like, whatever we have discussed in the yesterday's class. Just a second. These were all the just introduction discussion. Today we'll be having questions. Okay, then you will get to know what are the uses of the concept which we were discussing yesterday. So fill in the blanks question I'm taking. You tell me what we need to fill in the given plan. A tangent to a circle intersects it in dash point. A tangent to a circle intersected in tangent circle को कितने points पे touch करके निकलता है? How many points? If you are drawing a tangent in a circle, it touches the circle at how many points? Anyone? Yes? Can you hear me?
1
Yes,
point.
ma'am.
It just touches the circle at one. Yes, I am. It just touches the circle at one and only one point. That point is called point of contact. Okay. So tangent to a circle intersect it in one point. Okay. Next. A line intersecting a circle in 2 points is called a
Secant.
secant. Okay. Such a line is called a secant. Next, a circle can have dash parallel tangent at most. एक बार में कितने parallel tangent हम draw कर सकते हैं एक बार में? अगर हमारे पास एक सर्कल है और मैंने एक tangent draw कर दिया, इसके parallel और कितने tangents draw हो सकते हैं? इसके parallel भी होना चाहिए और tangent भी होना चाहिए.
1.
Okay, on this side. So at a time only 2 parallel line is possible, which are tangent, okay, which are tangent also and are parallel also. Tangent also, parallel also. At a time only 2, at maximum 2 possible. Okay. What I am writing, I am about to write 2. Maximum 2 I was about to write. Okay, because at most this word is given. A circle can have 2 parallel tangents at most. At most means maximum. Okay, is it clear to everyone? Is it clear? Next one. The common point of a tangent to a circle, and the circle is called the common point of a tangent to a circle, and the circle is called वो पॉइंट जो tangent और सर्कल का कॉमन पॉइंट है उस पॉइंट का क्या कोई स्पेसिफिक नेम है?
Point of contact.
It's point of contact. तो ये सारे जो हमने कल डिस्कस किया अपने क्लास में, ये सारे ऐसे फिल इन द ब्लैंक्स क्वेश्चन, ट्रू फॉल्स क्वेश्चन और सर्टेन रीजन बेस्ड क्वेश्चन वहां से आते हैं. ओके, लेट्स कंटिन्यू. We have also discussed one theorem. The theorem was the length of tangents drawn from, wait, not this theorem, the first theorem. This one we have not started the discussion. The tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, what the theorem says? The theorem says that the tangent at any point of a circle. Suppose we are having a circle and I am drawing a tangent at any point. Suppose we are having a circle and we are drawing a tangent at any point. Okay, let's call it point A. A is the point of contact. The tangent at any point of a circle is perpendicular to the radius. Now in this circle so many radiuses are there. This is also radius. This is also radius. This is also radius. Okay, so many radiuses are there. But this tangent is perpendicular to a special radius which passes through the point of contact. If the radius passes through the point of contact, okay, if this radius we are talking about, this radius must be perpendicular to this tangent. Okay, my figure is not that accurate because that's due to that it doesn't look like perpendicular, but okay, in a circle, एक सर्कल में बहुत सारे रेडियस होते हैं बट वो स्पेशल वाला रेडियस जो पॉइंट ऑफ कांटेक्ट को टच करके निकलता है, ओके, पॉइंट ऑफ कांटेक्ट को टच करे करता है या फिर पॉइंट ऑफ कांटेक्ट से पास होता है, वो रेडियस टैंजेंट के साथ 90 डिग्री क्रिएट करता है. यही हमें प्रूव करना है इस थ्योरम में कि हमारे सर्कल में अगर कहीं भी एक टैंजेंट है, कहीं भी एक टैंजेंट है, तो पॉइंट ऑफ कांटेक्ट से जो रेडियस हम ड्रॉ करेंगे, ये स्पेशल रेडियस, ये रेडियस टैंजेंट्स के साथ 90 डिग्री क्रिएट करेगा. दैट्स व्हाट वी आर गोइंग टू प्रूव ओवर हियर, दैट इट विल बी 90 डिग्री ओवर. Am I making sense? Is the theorem clear to all of you? Is it clear?
Yes, ma'am.
That radius passes through the point of contact will create 90 degree over there. Let's prove it. So the same logic I am going to just write it over here. It's very simple. Okay, they will be saying that suppose here we are taking a point P, here we are taking a point Q, here very close I am taking a point M. we know. Okay, you can write it what you have to prove. We have to prove that OA is perpendicular to RS. Okay, okay. Here we know that this OA is the radius. Okay, OA is the radius, and if we are joining O with P, सर्कल के बाहर एक पॉइंट P है जिसे हम सेंटर से ज्वाइन कर रहे हैं, तो ये रेडियस से बड़ा है ये लेंथ. OP is bigger than OA. Why? Because OA is the radius and OP we can see it is bigger. That doesn't need any explanation. सर्कल के बाहर कोई भी पॉइंट अगर सेंटर से ज्वाइन करेंगे तो वो रेडियस से बड़ा ही होगा. Okay, it will be larger than the radius. Similarly, we can see that if we will join OQ or maybe you will join OM, these all the lines are bigger than OA. OA is a radius. Okay, so we can see that OQ is also bigger than OA. OM is also bigger than OA. That means it seems like OA is the shortest distance from the center.
Ma'am, can you scroll up? Ma'am, could you please scroll up?
Is it okay?
Yes. Okay.
Therefore, OA is the shortest distance distance of the center from the tangent RS. Hence, OA must be perpendicular to RS. Hence, that's what we wanted to prove. Everyone getting it what I am writing over here? Is it making sense to you? Since OA is the shortest distance, it must be perpendicular distance. Is it making sense? Is it making sense to all of you?
Yes, ma'am.
Okay, shortest
Yes,
distance
ma'am.
ही perpendicular distance होता है. Yesterday we were discussing it in our class. Okay, here we have proved it. It's very basic, very simple. Let me know once you are done till here. I'll scroll down.
10, ma'am.
Okay, let's move. Now, yesterday I was telling you, okay, we are done. Whatever we had discussed yesterday in yesterday's class, I have summarized everything how you will be getting those things in question. When you are having a circle, what is secant, what is tangent, what is point of contact, how many tangent can be drawn in a circle, how many tangent can be drawn at a particular point. So these are the concepts which we were discussing yesterday, and this theorem that shortest distance का मतलब ही होता है perpendicular distance and perpendicular distance का मतलब ही होता है shortest distance. Okay, so now if we are taking a circle, अगर इस सर्कल में कितने पार्ट्स हैं, लेट मी टेल यू. एक इनसाइड पार्ट है, एक ऑन द सर्कल वाला पार्ट है, ऑन द सर्कल, एंड एक आउटसाइड पार्ट है. जब भी हम अपने पेपर पे या स्क्रीन पे एक सर्कल ड्रॉ करते हैं तो हमारा जो स्क्रीन है वो 3 पार्ट्स में डिवाइड हो जाता है. एक जो सर्कल के इनसाइड वाला पार्ट है वो, एक जो सर्कल के ऊपर पॉइंट्स है, जो सर्कल के ऊपर वाला पॉइंट्स है, दैट्स okay, that is another part, and the circle outside the circle. Now if I am telling you that I'll be giving you a point inside the circle, if I am giving you a circle and there is a point P which is lying inside the circle, now from this point P how many tangent can be drawn? Can you tell me? अगर सर्कल के इनसाइड वाले रीजन में कोई पॉइंट P है तो उस पॉइंट P से पास होने वाला कितने tangents ड्रॉ कर सकते हैं? Anyone? Is it possible
0.
to draw? It's not possible to draw a tangent from P, क्योंकि tangent का मतलब ही होता है एक ऐसा लाइन जो सर्कल को सिर्फ एक पॉइंट पे टच करने की. Okay, this point P, from passing through this point P, if you will draw any line, okay, it will look like this. This is not a tangent, or maybe it will, whatever way it will look like, tangent is not possible in this case. So अगर एक point circle के inside region में lie करता है, then no tangent possible. Okay, fine. Now the next condition is if I'll draw a circle and I will give you a point on the circle, and again I am asking you how many tangents are possible through this A, through this point A,
1.
how many? Yes, one and only one tangent. Okay, so passing through A, passing through A, maximum one tangent is possible. ओके, सर्कल के इनसाइड रीजन की बात हो गई. सर्कल के ऑन द सर्कल वी हैव हैड द डिस्कशन, अगर कोई पॉइंट हो तो कितने टेंजेंट्स पॉसिबल है. अब कोई अगर पॉइंट सर्कल के बाहर लाई करे आउटसाइड रीजन में, तो यहाँ से कितने टेंजेंट्स पॉसिबल है? यस, थिंक अबाउट इट. Maximum 2 tangents will be possible. Let me draw. Passing through P. Look like this. Okay, it will look like this. So if a point is lying outside the circle, maximum 2 tangents can be drawn. And when we will draw a tangent like this, then we will find that length of the tangent are same. Let me explain you. जब भी हम आज के बाद से लेंथ ऑफ टैंजेंट की बात करेंगे, ओके, तो हम कौन से लेंथ की बात करेंगे? ये जो टैंजेंट है, ये तो वी कैन ड्रॉ इट, इट विल गो टिल इंफिनिटी, आई कैन स्ट्रेच दिस लाइन आल्सो। बट जब भी हम लेंथ की बात करेंगे, दैट मीन्स हम बात कर रहे हैं पीए की, पॉइंट ऑफ कांटेक्ट तक का लेंथ हम बात कर रहे हैं। जो एक्सटर्नल पॉइंट है वहां से स्टार्ट हुआ एंड पॉइंट ऑफ कांटेक्ट तक की लेंथ बात कर रहे हैं, इसे कहते हैं लेंथ ऑफ टैंजेंट। तो अगर क्वेश्चन में लेंथ ऑफ टैंजेंट ये टर्मिनोलॉजी दिया हो तो हम कंफ्यूज नहीं होंगे। हम ध्यान से देखेंगे जो आउटसाइड जो एक्सटर्नल पॉइंट है, वहां से लेके पॉइंट ऑफ कांटेक्ट तक बस हम उसी लेंथ की बात कर रहे हैं और उसे ही हम लेंथ ऑफ टैंजेंट बोलेंगे। ओके, PB is also the length of tangent, and here in such scenario we will find that both the lengths are exactly same। जब भी हमारे पास एक्सटर्नल पॉइंट होगा और उस एक्सटर्नल पॉइंट से मैक्सिमम हम दो ही टैंजेंट ड्रॉ कर सकते हैं, और जब हम ये दो टैंजेंट ड्रॉ कर देंगे तो हम पाएंगे कि ये दोनों टैंजेंट का लेंथ तो सेम ही है। ओके, वी विल बी प्रूविंग दिस। If you will do the construction, you will find it the length will be same, but we will not do the construction, we will be proving it with the help of congruency. This two length will be equal with each other. Tangent drawn from external point are equal in length. That's the theorem which we are going to prove now. तो अगर fill in the blanks question, true first question, reason assertion based question में ये लिखा हो कि अगर एक पॉइंट सर्कल के इनसाइड रीजन में लाई करता है, उससे कितने टैंजेंट हम ड्रॉ कर सकते हैं, तो नो टैंजेंट कैन बी ड्रॉ। अगर एक पॉइंट सर्कल के ऊपर लाई करता है ऑन द सर्कल, whenever I am saying circle, think about it as a circular ring or maybe a bangle, okay, on the circle कितने tangents ड्रॉ कर सकते हैं, तो एक और सिर्फ एक ही टैंजेंट ड्रॉ कर सकते हैं। अगर कोई पॉइंट ऑन द सर्कल पे स्पेसिफाइड है तो उससे पास होने वाला एक टैंजेंट पॉसिबल है। अगर कोई पॉइंट सर्कल के बाहर दिया हुआ है तो उससे पास होने वाला मैक्सिमम दो टैंजेंट्स पॉसिबल है, और दोनों ही टैंजेंट का लेंथ आपस में इक्वल होंगे। किसे हम लेंथ कहते हैं ये हमें अच्छे से समझ में आ रहा है। एक्सटर्नल पॉइंट से शुरू होकर पॉइंट ऑफ कांटेक्ट तक इसी लेंथ की हम बात करें, क्योंकि ये लाइन को जितना हम चाहे स्ट्रेच कर सकते हैं, तो इंफिनिटी तक we will not consider, we will be only taking till point of contact. Okay, let me write the theorem and let's prove it. The lengths of tangents drawn from an external point to a circle are equal. This is the theorem. Okay, let's prove it. If we are having a circle, if there is external point P, then we are trying to prove that PA and PB two are equal in length. Okay. Now here I am taking the center O. ध्यान से देखो, पहले समझेंगे फिर प्रूफ करेंगे। यहाँ कंग्रुएंसी की हेल्प लेंगे। तो हमें पता है कि ये जो सर्कल है इसमें बहुत सारे रेडियस हम ड्रॉ कर सकते हैं। दिस इज ऑल्सो रेडियस, दिस इज ऑल्सो रेडियस, दिस इज ऑल्सो रेडियस। हाउएवर जब भी हम एक ऐसा रेडियस ड्रॉ करते हैं जो पॉइंट ऑफ कांटेक्ट को टच करे, या फिर पॉइंट ऑफ कांटेक्ट से पास करे तो ये रेडियस बहुत स्पेशल होता है, ये यहाँ पे 90 डिग्री क्रिएट करता है। क्या हमें ये पता है? डू वी नो दैट? Do we know that OA will be perpendicular to this tangent? Yes or no?
Ma'am, can you repeat it?
एक सर्कल में बहुत सारे रेडियसेस होते हैं, बट हमें पता है वो एक स्पेशल रेडियस है जो टैंजेंट के पॉइंट ऑफ कांटेक्ट को टच करता है। ये रेडियस टैंजेंट के साथ 90 डिग्री क्रिएट करता ही है, ये हमें पता है। आया ना? अभी अभी हमने प्रूव किया ना, दिस इज द शॉर्टेस्ट डिस्टेंस एंड इट विल बी परपेंडिकुलर टू द गिवन टैंजेंट। यस और नो?
Yes.
Okay, that means OA is perpendicular. Okay, OA is per here it 90 degree we are getting. Similarly, when I will join the center O with the point of contact B, this this is also a special radius. क्यों? क्योंकि ये radius point of contact से pass हो रहा है और यहाँ भी 90 degree create होगा. Let's read the previous theorem. Just now we have proved it. The tangent at any point of a circle is perpendicular to the radius which passes through the point of contact. Okay, through the point of contact means which passes through the point of contact. Tangent is perpendicular to the radius. Which radius? Which passes through the point of contact. Are you getting it? Now only we have proved this theorem. Tangent line will be perpendicular to the radius. Which radius? In circle so many radiuses are there, so that particular radius which pass through the point of contact. Are you getting it? We are going
Yes,
to use
ma'am.
this theorem. We are going to use this theorem over here that we know already. We know already that this OA will be perpendicular to PA and OB will be, this is O, OB will be perpendicular to PB, because tangent at any point to tangent at any point to the circle, okay, is perpendicular to the radius through the point of contact. Let me write it. We know that OA is perpendicular to PA and OB is perpendicular to PB. Why? Because tangent at any point the circle is perpendicular. Tangent is perpendicular. Basically, that's I'm writing. Tangent is perpendicular to the radius through the point of contact. That means which passes through the point of contact. Okay. We know this theorem and from there we are declaring it. What we have to prove over here? We have to prove that P and PB are same in length. We have to prove that, okay, PA is equals to PB. Now we will be taking triangle. Which triangle? We will be taking triangle. ध्यान से देखो. We will be taking this triangle and this triangle, and we will try proving it correctly. These two triangles we will be taking and we will try proving this two triangle congruent. That means we are going to take triangle OPB and triangle OPA. Let's take it. I'm writing over here. Triangle. Let me write it different. Triangle OPA and triangle OPB. Okay, after this one, you have to see this part. Here can we say that OA and OB are same because both are radius of the circle? Can we say that? Yes or no? OA and OB will be same. Yes or no?
Yes, because they are the radius.
They are the radius. We know that. 90 degree over here, 90 degree over there. Okay. Angle OAP is equals to angle OBP. 90 degree each. Okay. Now only we have written the theorem also in we know part. And OP is the common side. So which congruency criteria is working? It looks like 90 degree, then hypotenuse, then one of the side. Yeah, RHS. Can you see it? RHS congruency is working over here. Let me write the proper name. What will be the proper name? Let me check the name I have written. Is it correct? OPOP. Okay.
Yes, ma'am.
OA, OA, OB. Okay. Angle A over here. Yeah. The name which I have written. That is perfect. And the triangle OPA is congruent with triangle OPB. Do it by yourself. This is all the step which I am writing over here. Triangle OPA is congruent to triangle OPB. Hence, by CP PA is equals to P. Yes or no?
Yes, ma'am.
We are done. Okay. First finish it, then we'll be moving. Let me know once you are done. I'll be taking questions now.
Done, ma'am.
Done. Yes, everyone. Rest of the student, are you done?
Yes, ma'am.
Okay, let's start. So, इस चैप्टर में सिर्फ और सिर्फ दो ही थ्योरम। एक थ्योरम ये कहता है कि वो जो रेडियस है स्पेशल वाला वो पॉइंट ऑफ कांटेक्ट के साथ 90 डिग्री क्रिएट करता है, और दूसरा थ्योरम ये कहता है कि अगर एक सर्कल के बाहर एक पॉइंट है, एक्सटर्नल पॉइंट है, तो उससे सिर्फ और सिर्फ दो ही टैंजेंट ड्रॉ किए जा सकते हैं, मैक्सिमम टू, और ये दोनों टैंजेंट का लेंथ आपस में सेम होगा। लेंथ ऑफ द टैंजेंट जब भी हम बात करते हैं तो कौन से लेंथ की बात करते हैं ये हमें अच्छे से क्लियर है। अब चलो क्वेश्चन सॉल्व करते हैं। Just a second, let me take a look at this one. Yeah, a tangent PQ at a point P of a circle radius 5 centimeter meets a line through the center of at a point Q, so that OQ is equals to 12 centimeter length, PQ is, okay, figure is not given, we have to draw the figure by ourselves. Let's draw it. A tangent PQ, okay, a circle is there and tangent PQ at point P of circle. At a point P, we are having the tangent PQ, okay, of radius 5 centimeter. Somewhere Q is there. I'm writing this P and Q like this. Okay, radius is 5 centimeter. So in this circle, we know that radius is 5 centimeter. Okay, meets a line through the center O at wait, tangent PQ at a point P of a circle of radius 5 centimeter. Tangent meets a line through the center O at a point Q, so that OQ is 12 centimeter. This OQ is given as a 12 centimeter. Okay, this much is given as a 12 centimeter. And OP is also a radius, we know that already. And this is a special radius. OP is also 5 centimeter. Okay, OP is also a radius, we know that already. And OP is, this is a special radius which will be making 90 degree over here. We know from the first theorem. Okay, what we have to find PQ. Can we see that we are having a right angle triangle like this, where this side is 12, this side is 5, and it is 90 degree. So can we find this PQ by Pythagoras theorem? Can we? Can we? Yes or no?
Yes, ma'am.
Okay, it is very simple. The first theorem is helping us to understand that this is not random triangle. This is a right angle triangle, and if this is a right angle triangle, then finding PQ is very simple. Okay, tangent PQ we are having at a point P. That means tangent is touching the circle at P. Okay, at point P of a circle. Can you see it is written? Accordingly, I have drawn the tangent. Radius is 5 centimeters, so of course OP will be 5 centimeters. It is a radius, and here we'll be having 90 degree. We know that. Okay, meets a line through the center at a point Q. The center and the point Q, it's creating a line. Basically, that's what is said. So that OQ is 12 centimeter. Okay, OQ is 12 centimeter. Hence, find PQ. We'll be able to find PQ by Pythagoras theorem. Okay, how we'll be writing it? We will be writing it. We know that. We know that OP is perpendicular to PQ. Again, the same theorem. Tangent at any point to the circle is perpendicular to the radius through the point of contact. Okay, is perpendicular to the radius through the point of contact. Now, in triangle PQ, use Pythagoras theorem, write it that OQ square is equals to OP square plus PQ square, and from there we'll be able to find PQ. PQ will come out as a plus minus sign, but we'll be taking the plus sign because we are talking about the length only. Getting it? Is it clear to all of you? Please finish it and tell me what are you getting as a PQ.
Ma'am, what is after the point?
Point of contact. ये थ्योरम लर्न इट, ओके। सिर्फ दो ही थ्योरम है, लर्न कर लो इन दोनों थ्योरम को। टेंजेंट एट एनी पॉइंट टू द सर्कल इज परपेंडिकुलर। कहाँ पे परपेंडिकुलर है? टू द रेडियस थ्रू द पॉइंट ऑफ कॉन्टैक्ट।
Ma'am, is the answer root 119 centimeters?
Yes, it can come in root. Okay. Yes, everyone getting the same. Are you getting 119 inside the square root? Rest of the student. Okay. Yes, it can come in square root. We'll be taking the positive one since we are talking about the left. Okay. Let's move. Rest of the student, are you even doing it?
Yes, ma'am.
What are you getting? Please tell me. Are you getting the same? Pythagoras theorem apply करना है हमें यहाँ पे.
I'm getting root 1.
Getting root 119. Okay. So PQ will be under root 119. Okay. Centimeter is given for all the other unit. Here also centimeter. अब हमारे पास एक क्वेश्चन. In figure, if TP and are two tangents to a circle with center O, show that angle P of U is equals to 110 degree, then angle PTQ will find them. Okay, let me draw the figure. Okay, it looks like this. This angle is given as 110 degree. Okay, what we have to find, this is the center. What we have to find, we have to find this angle. Okay, this angle. Any idea how we'll be finding this angle? See, TP and TQ are the tangents. TP and TQ are the tangents. And we have to find what will be the angle T over there. Yes, everyone. Any idea? कैसे हम फाइंड करेंगे एंगल T? अगर हमें एंगल O दिया हुआ है 110 डिग्री,
Can we construct a line?
we will construct a line. Suppose I will be joining this group. Will it help? उसके बाद क्या करेंगे आशा? हमें सिर्फ दो ही थ्योरम पता है इस चैप्टर में, सारे क्वेश्चन सॉल्व हो जाएंगे ये दो थ्योरम. या टेल.
Can we take first triangle POT?
If we will be taking TOT, then what will we do?
We have one right angle triangle.
Right angle. Then
An angle 110. Should we divide it by 2?
मे बी, बट उसके लिए तो पहले दिखाना पड़ेगा कि ये दोनों कॉन्ग्रुएंट है, तभी हम 2 से डिवाइड करें. Yes, this way, that way. Like if we are drawing a line, angle O over here, angle O over there will be same. But उसके लिए पहले हमें दिखाना पड़ेगा. We have to show that these two triangle are congruent. Okay, बिना वहां से भी हमें find, we will be able to find that angle T. What is angle T? Okay, Aisha, whatever you are saying that will help. अगर हम सबसे पहले दो ट्रायंगल में ऐसे डिवाइड कर लें और उसके बाद हम ये बोलने की कोशिश करें कि एंगल ओ, यहाँ पे जो एंगल ओ हमें दिख रहा है ना, ये हाफ होगा 110 का. उसके लिए पहले हमें साइड में ब्रैकेट में या फिर फेयर क्वेश्चन में दिखाना होगा कि ये दोनों ट्रायंगल कन्वर्जेंट है, तभी हम बोल रहे हैं कि एंगल ओ हाफ होगा. ओके, 110 का. या फिर एक इजियर मेथड है जो हमें कह रहा है कि बिना इतना कुछ किए भी हम फाइंड कर सकते हैं एंगल. ध्यान से देखो, ध्यान से देखो, ये जो फिगर है, ये क्या कोई एक क्वाड्रिलेटरल जैसा दिख रहा है? आया ना?
Yes, ma'am.
क्वाड्रिलेटरल के तो सारे ही इंटीरियर एंगल का सम क्या होता है? क्या होता है
360.
क्वाड्रिलेटरल?
360.
के क्वाड्रिलेटरल के सारे ही इंटीरियर एंगल का सम तो हमें पता ही है 360 डिग्री. यहाँ सेंटर पे क्या क्रिएट हो रहा है? 110. यहाँ 90 डिग्री, यहाँ 90 डिग्री. हमें पता है, हमारे पास थ्योरम भी है जो इसे सपोर्ट करेगा. और एंगल टी हमें फाइंड करना है, तो हम तो बहुत आसानी से फाइंड कर पा रहे हैं. अगर लाइक इफ यू कैन सी ओवर लाइक द angles, each interior angle, 90, 110, 90, angle T. Will it be possible to find? Yes or no?
Yes, ma'am.
In quadrilateral, do it quickly. Yes, Aisha, are you getting it? POQT, angle P plus angle O plus angle Q plus angle T is equals to 360 degree. Now angle P will be 90, angle Q will be 90, angle O is 110, angle T you have to find. But write it in a bracket again, the same theorem. Tangent at any point to the circle is perpendicular to the radius through the point of contact. Is it crystal clear to all of you? Tell me the answer.
So 70 degrees.
So we'll be getting 70 degree over here.